Alright, welcome to Algebra 1 and welcome to one of the first videos we have for Algebra 1. Today we're going to be reviewing one-step equations because we're eventually going to go to two-step equations and then equations with variables on both sides. So we're going to do a lot of review, make sure we really understand the basics before we move on. These videos, they are intended for you to be able to pause, rewind, and watch as many times as you need for you to go back and make sure you have this information. It is available to you all the time throughout the year, so feel free anytime to go back and watch these videos as many times as you need, as slow as you need, any of that, so that you get this information. So let's talk one-step equations, or just solving equations. Anytime there is an operation, in order to solve it, you are going to undo it. So the inverse, we call this inverse operations. So the inverse operation of addition, what's the opposite of addition? That's subtraction. What's the opposite of subtraction? Addition. The opposite of multiplication is division. Now there in Algebra 1, there's a few ways you're going to see multiplication written in an equation. You could see it written as something like 3x, where they're next to each other, or you could see it written as 3 parenthesis x. You're going to hear me say many times this year, if it's next to each other, what does it mean they're doing? They are multiplying. There's not an addition or subtraction in between. If they are right next to each other, that means they are being multiplied. So to undo multiplication, what we're going to do is divide. And then the last one, how do you undo division, or what's the opposite of division? Opposite of division is multiplication. And again, how are you going to see division in equations in algebra? It's going to look like a fraction. Fractions are divisions. So it's going to be like x over 3. So anytime you have a fraction with the variable, you're going to hear me say the word variable a lot. Variable is the letter. Whenever the variable is in the numerator, that means that the denominator, that the variable is being divided by the denominator. Okay, numerator's up there at the top, denominator's in the bottom, using lots of vocab on day one. That's what we do. Okay, so again, x over 3 means x is being divided by 3. So how would we undo dividing by 3? We would multiply by 3. So when we move on to multi-step, today we're not going to do multi-step or two-step, we're just going to be doing one-step. So if we have multiple pieces happening at the same time, how do we know which one to do first? You're going to work your way out to in, or you're going to work the way farthest away from the variable that you're looking at, or the farthest away from the x. It's usually x, but sometimes we throw in some n's and some a's and some b's, okay? So what is happening farthest away from x? That really comes into play when we do two-step equations and variables on both sides equations, like we're going to do tomorrow and a couple days from now. So just be ready for that. So let's look at this first example. There's lots of examples here. X plus 4 equals 2. So what is currently happening to my x is it is being added by 4. So how do you undo adding 4 is you subtract 4. And what you do to one side, you have to do to the other. So I don't know what happened in the 7th and 8th grade pre-algebra classes and how you were taught. I have seen students draw the line down the equal sign, so that way they are sure to know if it happens on this side of the equal sign, it has to happen on that side of the equal sign. So feel free to keep doing that. If you have never done that before and you're like, wow, that really helps, great, let's keep doing it, okay? So on the first few examples, you'll see me draw the line down the equal sign. So I'll be sure what I'm doing to one side, I have to do to the other. Because if I subtract 4 and I don't do it to the other side, I've changed the equation. I've created a misbalance, okay? So if I'm wanting to keep this balanced, subtracting 4 on one side, I have to subtract 4 on the other. Or what I do to one side, whether it's adding, subtracting, multiplying, dividing, all the things that we're going to do with algebra for the rest of our lives, what I do to one side, I have to do to the other side of the equal sign. Okay? So if I subtract 4 from one side, I'm going to subtract 4 from the other side. So my plus 4, my minus 4. What is plus 4? A positive 4 minus 4? It's 0. So that's what we call canceling out, because it cancels to 0. The only thing I'm left with on the left side is x. And then 2 minus 4 is negative 2. If that math is not coming to you straight away, please use a calculator. If you think it's negative 2, you can always use a calculator to check your brain. No harm in that. But what I'm actually going to do right now is I'm going to check to see if my answer is correct. So I'm going to plug in negative 2 back in for x because that's what I say x is equal to. If I say x is equal to negative 2, then I'm going to plug negative 2 back in for x. So negative 2 plus 4, I'm going to use my calculator, or I can use my brain. Negative 2 plus 4 is 2, which is what my equation says it is. All right, second example, 3 plus x equals negative 5. So x is what I'm solving for, so the 3 is what's happening to it. Now, again, I can draw the line down the equal sign so I can make sure like what I'm doing to one side, I'm also doing to the other side. But now that 3, what is that 3 currently doing? Or how do I get rid of a positive 3? If you don't know what that 3 is doing yet, that's fine. That's fine. But I want to cancel. I want that 3 to go away. So how do I get rid of a positive 3? Is I subtract 3. And again, what I do to one side, I have to do to the other side. Again, that's me showing that I canceled that side out. So all I'm left with on the left side is x, and negative 5 minus 3 is negative 8. Again, if you want to check your brain with the calculator, feel free. And again, you can go back and plug it in. If I have 3 plus negative 8, does that give me negative 5? And it does. Right? Next example, 7 minus x equals 3. Now, again, these are one-step equations, so could you use your brain and do these? Absolutely. If you can automatically think about what that is great. When we start getting into two-step and multi-step and a whole bunch of extra stuff, those will be a little bit harder to do in your head. So for today, I do still just want us to go through those steps to show so that when we have more complicated things, we can be sure we understand how to do the easy things. So what I want, again, I could draw the line down the equal sign. I'm not going to this time, but what is currently happening to x, or what is on the same side of x, is that minus 7. How do I undo, or how would I cancel a minus 7? Is I would add 7 to both sides. So if I add 7 to this side of the equal sign, I have to add 7 to that side of the equal sign, and I get x is equal to 10. Again, I could have known that when I plugged that in the beginning, what minus 7 is going to give me 3, and I'm sure a lot of us could have figured out that that was going to be 10. Now here, I have negative 4 plus x equals negative 2. Again, I could use my brain. Negative 4 plus what is going to give me negative 2? Or I could think, okay, I just got to go through the steps. What is happening on the same side of the x is a negative 4. How do I cancel out a negative 4? Is I'm going to add 4 to both sides. Negative 4 plus 4 is going to give me the 0 that I need. So I have x equals, and negative 2 plus 4 is a positive 2. Again, you can use your calculator to check your brain. Negative 2 plus 4, it's already there. But I'm going to go back and check my answer. So if I do negative 4 plus 2, I get the answer that it says. It says I get a negative 2. Now, those are all my adding and subtracting ones, where all I had to do to undo it was add or subtract. Now I have ones where I have no visible operations. The operation is there just because they're sitting next to each other. So I have 4x equals 12. Now again, I know we are smart. I know that we can use our brains, even though we're just coming back from summer. 4 times what is going to give you 12? Because that's what that is saying. 4 times what? Times, because they're next to each other. 4 times what gives you 12? I know, we all know that that's 3. But let's mathematically prove how to find out that it's 3. Okay? So again, you'll hear me say this all the time. What is that 4 currently doing to that x? That 4 being next to it means that they are being multiplying. So how do you undo multiplication? Is you divide. So I draw my divisions like fractions. So I'm going to divide by 4 on both sides, because what I do to one, I have to do to the other. You'll see me cancel them out, because if I have a 4 over 4, it cancels. It cancels to 1, okay? And 1x is the same thing as x. And then 12 divided by 4 is 3. And we knew that was going to be 3, because 4 times 3 is 12. Now here's another way that you could see multiplication. You could see it in parentheses. Now there's nothing else happening in those parentheses, so there's not really a need for them, but you just never know what's going to show up. So this is the exact same thing as 3 times x equals 8. And that one's not as easy to do in your head. That one's not as easy, because if you think about it, 3 times 2 is 6. That's not there. And then 3 times 4 is 12, and that's not there. 3 times 3 is 9. That would have been the number in between. 3 times 3 is 9, and that's not there. So what is this one going to be? So again, how do you undo multiplying by 3? You divide by 3. And I get x equals, now I'm going to use my calculator, 8 divided by 3. And I get this lovely decimal. Now, we don't like decimals around here. So the buttons that you're going to press in your calculator are going to be math, enter, enter. And that will, in the calculator, that will automatically put it back into a reduced fraction. Improper fractions, they're great. Okay? Mixed numbers, no. Those are only good for baking. But improper fractions are what we're going to be using and what you're going to be using for most of your math, definitely for all of your algebra for the rest. Okay? Improper fractions, where you have the numerator is going to be potentially larger than your denominator. Okay? So this one is 8/3. Okay? So again, I wrote it on my notes here, the buttons that you press in your calculator. It is math, enter, enter. All right, now this one. I have negative x equals 3. Again, you might be thinking like, I already know what this is. Yay, I'm very happy for you. There is an operation, and there definitely is an operation because there's a negative in front. There also is a number in front. And I'm going to encourage you, and I will do it every time, if there is not a number out in front of a variable like that, to rewrite it immediately as a 1. That is a negative 1x equals 3. So now it's a little easier to say, okay, well now what is being multiplied to the x? Because it's a little bit harder, like, well, I know a negative is being multiplied by x, but how do I undo a negative? Do I add a negative? Well, add what? How do I divide a negative? Well, okay, divide by what? So if you put a 1 there, then you get a number that you can also divide by, and it just makes life so much easier. So so now I can see that that is negative 1 times x. So how do I undo multiplying by negative 1? Is I'm going to divide by negative 1 on both sides, and I get that x is equal to negative 3. Again, if I were to go back and plug that in, negative, negative, negative times a negative turns back into a positive, and so that's where we get that positive 3. Right here, I have 1/4 x equals negative 2. I have a 1/4. We are not going to be afraid of fractions. Not in this class. There is nothing wrong with fractions, okay? It's just division. So what is that 1/4 currently doing to that x? That 1/4, since it's next to each other like that, that 1/4 currently means that it's being multiplied to x. So how do you undo multiplication? You divide. So I'm going to divide both sides by 1/4. Now, that's a little ugly to do in your head, so you could use your calculator. Negative 2 divided by 1/4. Now, you'll notice with these calculators, you have to put fractions in parentheses. So the parentheses are right there above the 8 and the 9, and to put a fraction, it's division. So you're going to do negative 2 divided by, because that's what I'm doing, and then in parentheses, I'm going to put 1 divided by 4. And then I'm going to press enter, and I get that that is equal to negative 8. So x is equal to negative 8. Now there is another way to do this, because dividing by a fraction, you might have had a teacher at some point in your life saying, you never divide by a fraction. And that's kind of true, if you're doing it in your head. Now calculators, you can do anything because your calculator is very, very smart. But how else could you undo a fraction is you could multiply by the reciprocal, meaning you flip the fraction. So how do I undo 1/4? Is I multiply by 4/1. And then you'll see kind of cross multiplying, everything cancels. But what I do to one side, I have to do to the other. So those are going to cancel out and I get x, and -2 times technically 4 is just -8. So you're going to get the same. My last example, I have x over 3 equals 5. And again, this is almost the exact example that I showed you before. I'm trying to get x by itself, and what is that 3 currently doing? Well, it looks like a fraction, and a fraction is the same thing as division. So how do you undo dividing by 3 is you multiply by 3. Multiplying by 3 is going to cancel it, but what I do to one side, I have to do to the other. And so I get x is equal to 15. Again, could have done this one in your head, or you could plug it back in your head. 15 divided by 3 absolutely equals 5. And that is a review of one-step equations.